Okay, so I asked you to calculate the correlation coefficient for these variables. And also you can follow the same approach here. You need covariance and two standard deviations. And covariance is known. We calculated the covariance, which was minus 270. And then what you need is the standard deviation for W and Z. And you may use this rule. In chapter 4, we learned when you have a linear relationship, linear transformation, the standard deviation is multiplied by the multiplicated number. So if you take this form, then standard deviation can be easily calculated, which is like this. We know the standard deviation for x and for y. So standard deviation can be easily calculated, and in the end, you will get the same correlation coefficient. And like you may understand it this way. Look at this. The standard deviation is affected only by the multiplied number, which is 1.8, 1 over 1,000. And earlier, I showed you the covariance is affected by 1.8 and 1 over 1,000. So in the new covariance, those two multiplied numbers will be cancelled when you standardize using those two standard deviations. So standard dividing by standard deviations will fix the unit change. We'll cancel out the unit change. So as a result, the correlation coefficient will not change. Right? So from this, you can tell both the direction and the strength. And again, to summarize, the covariance only shows the direction, but the magnitude of the absolute value of the covariance means nothing, has no direct interpretation. However, the correlation coefficient has the direction and the strength. The sign is the direction and the absolute value is the strength. Remember, the correlation coefficient is always between +1 and -1, so you can tell how strong the relationship is. Okay, and later, maybe after this video, I will make another video to show you how to use covariance and correlation in Excel. It may be helpful for homework, and if you are already familiar with them, you don't need to watch that. But there will be a separate video for this. And now let's think about another example about macroeconomics. Suppose that there are 5 macroeconomics from like 1962 through 2015. And those 5 variables are really important variables in macroeconomics: GDP growth rate, industrial production growth rate, and consumer price index, inflation rate, unemployment rate, 10-year treasury bill rate. So anyone knows that those are important variables. And we would like to study the relationship among those 5 variables. But the problem here is that the covariance and the correlation coefficient cannot be applied to more than 2 variables. So we have 5 variables together, but there is no covariance that shows the relationship among 5 variables at the same time. Therefore, to apply the covariance, we have to calculate the covariance for each pair. So using the 5 variables, you can choose different pairs, and for each pair, there is a covariance. Then, as a result, you can make a covariance matrix. I will also, in another video, I will show you how to make this table in Excel. But in this video, I'm going to just assume that you have the table. So let me interpret what this table means. first, the table has entries: GDP growth rate, industrial production growth rate, inflation rate, unemployment rate, treasury bill rate, right? And same 5 variables. So 5 by 5, but upper triangle is empty. Let me explain the diagonal first. The diagonal, so like if you choose one entry, you can think it as an intersection of two variables. So for example, 11.33 is the covariance. It is a covariance matrix. It is in the covariance matrix, it is the covariance between GDP and GDP, which is simply variance of GDP, right? So all the diagonal terms are variances. For example, 7.79 is the covariance between treasury bill rate and treasury bill rate, which is treasury bill rate's variance. So all of them are variances, right? And then lower triangle parts captures covariance. Idea is the same. Say for example, 7.66 is the covariance between industrial production and GDP. And say for example, 1.10 is the covariance between unemployment rate and treasury bill rate. So for each pair, you can find the covariance. And by the way, the reason why the upper triangle entries are empty is because, say for example, this entry here, you should have covariance between GDP and industrial production, which can be found here, IP and GDP. So there is no difference. So covariance between X and Y equals covariance between Y and X. The order between the two variables does not matter. So like you can just copy those numbers from the lower side to the upper side. So because of that symmetry, it is useless. They will be duplicates, so they are empty. Anyhow, so all the entries capture covariance of a pair or variance of a variable, right? It's easy to understand. And then, by the way, it is a covariance matrix. So we can tell the direction of the relationship, but the strength of the relationship is not represented here. Like you cannot interpret what 7.66 means. So you cannot compare them. For example, so among these, if you look at this table, GDP has positive relationship with IP and TR, treasury bill rate and industrial production. So those two variables have positive relationship with GDP. But it has negative relationship with inflation and unemployment rate. What's interesting here is usually we expect high positive relationship with inflation. When the economy is in boom, usually inflation comes together. So one would expect a positive relationship between inflation and GDP growth rate. But according to the, by the way, the data is real. I use real data, real US data, and it looks like a negative relationship, which is not explained well by our macroeconomic knowledge. So of course, there are a lot of literature, a lot of economists have done something about this, explained this using more complicated model like expectation augmented, rational expectation models. So if you are interested, study more macroeconomics. Anyhow, we are doing statistics, so we can simply look at the basic relationship between variables. However, what you cannot do here is, suppose that GDP growth rate is positively correlated with industrial production growth rate and treasury bill rates. But it looks like industrial production growth rate has much larger covariance than treasury bill rate, but means nothing. Means nothing. So it does not say IP has stronger relationship with GDP than TR. So you cannot compare, say, the magnitude between two covariances because they do not have direct meaning. Then to compare them, like for example, you are wondering which variable has the stronger relationship with the GDP growth rate. Then you need to make the correlation coefficient, which is also you can calculate the correlation coefficient from the table. For example, think about inflation and unemployment. How can you calculate the correlation coefficient from the table? Think about that. The answer is, so the correlation coefficient is covariance divided by standard deviations. And covariances are given. This is the covariance, 0.48. Then you need to find the standard deviations, which can be obtained from the variances. So 8.26 is the variance for inflation, and 2.57 is variance for unemployment rate. So the answer is D. If you take square root of them, they are standard deviations. So using this, you can see the correlation coefficient is 0.1, right? Still positive. Of course, the sign does not change. And then, you may turn the matrix, the covariance matrix, into the correlation coefficient matrix. And of course, Excel does that for you. You don't need to do it by hand. And when you change everything into correlation coefficient, now the diagonal terms are always 1. You may think it this way. This is the correlation coefficient between GDP growth rate and GDP growth rate itself. So it's correlation between two same variables. So of course, it has to have, it must be a perfect correlation, right? Same variable. So all variables have diagonal terms have 1, and non-diagonal terms are correlation coefficients. Now you can compare the sign. Of course, the signs imply the direction, and the signs should be the same as the covariance matrix. But now you can compare, for example, the industrial production growth rate has stronger relationship with GDP growth rate than treasury bill rate, right? So you may compare 0.02 and 0.49, right? Which relationship is stronger? And let me ask you this way. Which pair has the strongest negative correlation from this table? Pretty simple, right? So the answer is this. So of course, we look at negative numbers over here, and among them, we have to choose the strongest negative side is the number closest to -1. So the absolute value is the largest from this covariance correlation coefficient. So unemployment rate and industrial production growth rate has the strongest negative correlation. So the answer is C. Right? This is it. And I'm going to finish it here. And as I promised, I will show you. I will demonstrate how you do this on Excel in a separate video, which is optional and which may be used for your homework, but you don't have to do that. Okay. Thank you for watching, and hope to see you later.